This is lecture 2 regarding the mathematical operation of the signals. So in this, like for example, in the mathematics, we have a rule called as board mass. Here we will be having a rule called FSTA. Okay, FASTA rule. F starts for the folding. Folding whenever you have to create any new signal. Okay, you have suppose, for example, I have given a signal x of t is equal to ramp of t. Okay, and from here, what I want is I want to generate a signal that is equal to ramp of t. You know already how the signal looks like. Ramp of t signal looks like this. This is your ramp signal. Okay, so mostly the slope is 1 and 1. Okay, suppose I take the signal up to here, 2 and 2, the slope is 1. Okay, slope means the change. Okay, dy by dx, like in the next lecture, in the previous lecture I have told you about this. Now if I want to get this faster rule, I have to get for folding. First folding means I have to get x of minus t. So it would be a mirror image of this. So I have to draw a mirror image. That means whatever is appearing on the right side, or simply I multiply this time x's by minus 1. So whatever is at 1 goes to minus 1, whatever is at 3 goes to minus 3, and whatever is at 4, and so on and so forth. Because see, I cannot see this signal is continuously increasing. Okay, so it will go this side round. So this will be the other way around. Now suppose I want to get a signal from this ramp signal. I have been given a ramp signal. I've been asked to construct a signal 2x, okay, minus 40 plus 8 by 2. 8 by 2. What do I do? I take this 2x, okay. I divide it by minus 4t divided by 2. So I'll get minus 2t plus 4 minus 2t plus 4. So immediately, how do I realize the signal? I'll do step by step. First step would be to realize x of minus t. Once I got x of minus t, then I will be doing this shifting. Okay, shifting operation. So shifting operation would be to realize x of minus t plus 4. Okay, this is x of, then I'll realize x of minus t plus 4, right? So I cannot directly write this. So what I do is I take this minus sign out. Okay, minus, then I write this t minus 4 here because minus and minus is plus. Now I know this minus 4 is representing me a time delay signal. So if it is minus 4 here, I have to add this signal here. So this signal will start at 4 now. Okay, I have to set because see, if it is 0 at minus 1, so on and so forth, this is at minus 2, this is at minus 3, and so on and so forth. And let's say this is at minus 4, the signal is at minus 4. So what I do, I add 4 to it. When I add 4 to it, what is my next signal that I'm going to get? I'm going to get this x of minus t plus 4, or in short, I'm going to get this signal. So in order to get this signal, okay, how do I go about it? I just add, okay, so 0, whatever is at 0 moves to 4, and whatever is at minus 1, it moves to 3. Whatever is at minus 2, it moves to, because I'm adding 4, it moves to 2. And whatever is at minus 1 plus 4, so on and so forth, I'll be doing it. So that means x of minus t plus 4 will completely shift. 0 value will shift to 4 and minus 4 value will shift to 0. Okay. So and another if I'm adding, like whatever the value was at minus 5 plus 4 I am doing, minus 6 plus 4 I am doing. So basically my signal x of minus t plus 4 I'll realize. Okay. Just a second. So here I have got, already I have got this x of minus t, which is a ramp of minus t. Now I'm realizing x of minus t plus 4. So whatever is the value there, right? And I wrote this as x of minus t minus 4, correct? X of minus t minus 4. So minus 4. So this value I need to add here plus 4. Okay. So whatever is 0. So my signal moves, right? Signal moves to 0. Amplitude of the signal. So it starts from 4 here. and the signal continues like this. So whatever was the value at 0 will move to 4, right? And whatever was at minus 1 plus 4 is 3, right? Then minus 2 plus 4 is 2, okay? And minus 3 plus 4 is 1, and minus 4 plus 4 is 0. It moves here, 0, okay? And if then after that, the amplitude C, whatever was the value at minus 5, it will come to minus 5 plus 4 at minus 1. Just you have to add by 1, okay? So on and so forth. I can redraw this till minus 2, and again I will keep the signal minus 3 and minus 4. The signal is growing, right? Minus 4. So the amplitude of the signal here at 4, the amplitude of the signal is 0, correct? At 3, you can see the amplitude of the signal is 1. At 2, it is 2, right? Let this be 1, okay? At 2, the signal moves to 2, okay? Again, at 1, the signal is moving to 3, and at 0, the signal moves to 4. So at this, it will move to minus 5, okay? So on and so forth. So at minus 4, you can see the signal is going ahead. It is going to 8, okay? Here, minus 6. Here, it would be minus 7, up till it is moving till 8, right? It is moving till 8. So the amplitude has nothing to do with this. So I realized the signal x of minus t plus 4. So I told you I'll be following FSTA rule. Okay, first I did folding. Okay, then I did scaling. Okay, and t here stands for, first I did folding, then I did shifting. Sorry, I shifted. Shifting basically means time advance or time delay, right? Shifting. Scaling means either multiplying or constructing it. And finally, I will multiply the amplitude, right? Amplitude scaling. So this is your time scaling. In time scaling, you saw what is the final result that I want in this signal. I want this signal to look like, this is my signal, 2x minus 2t plus 4, right? 2t plus 4. So till now what I have realized, till now I have realized this function x of minus t plus 4. Now I do need x of minus 2t plus 4. Now this minus 2t, what it is going to do is just going to see, just going to shrink the signal because I'm multiplying the signal. So it will only happen within the time axis, okay, x axis. So here I just need to divide the time axis by 4, by 2, because the value there is 2, na? So here also you can notice, you just need to divide the time axis, nothing else you need to do here. So if we take a different color, so here we divide the time axis by 2 everywhere. Okay, so this signal is going to shrink. So minus 2 is, minus 4 is coming back to minus 2, okay, and 4 is coming to 2, right? So now the signal value, whatever was at minus 4, it was 8, it will move to minus 8, minus 2. So the signal value, but the amplitude does not change. So the signal gets reduced to minus 2 to 2, okay? And the signal value at whatever was the signal value. So at the signal value as 4 was equal to 0, so at 2 it will be equal to 0, right? And 0 at 0 it was equal to 4. 0 divided by 2 is 0 only, so it will remain 4 there. And at minus 1, what was the signal value? You can clearly see at minus 1 the signal value was equal to your this thing, what do we call, minus 5. So it will remain there. At minus 2 it was equal to 8, okay? So the signal does not change, because you are doing it, so it will remain the same. So at 0 it was equal to, clearly we can see at 0 it was equal to 4, at minus 1 it was equal to 5. So the signal value will remain, okay? At minus 1, see, minus 1 it will not, see, minus 1 is now moved to point 0.5, okay, minus 1. So at this 2 point has moved to, so at the 2 point, whatever the value was there, 2 point is minus 6 value, right? Because you are dividing it by 2, na? So the signal value here would be equal to 6 at minus 1, okay? Minus 1, 6. And at minus 2 corresponds to 8, right? So the signal value was 8, so it will move like this. Okay, now the signal will become, at 2 it is 0, and 0 it is remaining 4, okay? At minus 1, you will get the same value that was at minus 2. At minus 2, you can see clearly it was 6. So here it would be 6, okay, and here it would be minus 8. So now you got the signal x of minus 2t plus 4. Okay, now you just need to multiply with the amplitude. Amplitude is over the y-axis. Okay, so you just need to multiply the amplitude. The final amplitude was minus 8, so it will move to minus 16. Okay, so at minus 2, the new amplitude would be minus 16. At minus 1, the new amplitude would be 12. At 0, the new amplitude would be 8. And 2, it is 0, because 0 into anything will remain the same. So now your new amplitude is shifting. So if you want to realize this function, final function like 2x minus 2t, so I'll be just showing you. So this is the final function that you will be retrieving. That is your 2x, 2x, where it went? Yeah, here it is. So you have this final function here, that is 2x minus 2t plus 4 minus 2t plus 4. So this function will be basically, here you notice, at 2 whatever the value was there, it will remain, right? Just you are multiplying with the amplitude. At 0 the value was minus 4, right? No, at 0 the value was yeah, minus 4. So at 0 the value is going to shift to 8, right? So it will shift. So here at 0 the value will shift to sorry, at 8, and at the 2 whatever the value was there, 2 minus 2 the value was 8 in the previous function, so it will move to 16 here. And at minus 1 the value was 6, okay, it will move to 12. Hmm? And at 1 you saw in the previous case the value was equal to 2, so it will move to 4, and at 2 it remains the same. So this is the final function you realize. Now let's take a similar example. We have a problem from a gate examination question. Let's see how to solve this problem. So it's a simple, it's asked for 2 marks. It's not a big deal there. So the question is like this. Just a second. Question is like this. It's been asked in gate for 208 for 2 marks. Hmm? So the question says you a signal is given to you. Okay, like this, a signal is given to you. So the signal is moving 0 at t. The magnitude of the signal is 1, and the signal goes like this. And here the value of the time is 2t, and this is your t. Now you have to get the signal. Okay, how do you represent this signal? If you want to write a mathematical equation for this signal, what you require to do? So you can clearly say the initial part of the signal, you can break the signal, right? You can break the signal from 0 to t and t to 2t. So if you notice in this particular case, how do you go about the value of the signal between 0 to t? What is the value of the signal between 0 to t? It can be clearly seen the amplitude of the signal is 1. Now, and then at t, it is becoming 0, right? So it is only possible if you have a unit step function and a shifted unit step function to get this slope. Suppose you have a unit step function u of t, right? Hmm? So u of t function will start from here, right? It will start from here, like this. This would be, and u of t minus t, t, t minus t. From where it will start? It will start from t, t value, right? Because if you are doing minus here, that means you are adding here. So whatever the value of 0 was there, it will shift to t, right? And if you are subtracting these values, right? So what will happen till here? The value was c. Between 0 to t, there is no value. Between 0 to t, here there is zero value. But at t, let's say this is t, it is declining, right? It is going down. At t, this value is declining. So if you do ut minus u of t minus t, you result at the first part of the signal, you will realize. See, at t, this, see, it will come like this at t, right? Because here the amplitude is 1 between 0 to t. A is equal to 1 till t. But here the amplitude is not there. Amplitude is 0. So this 1 remains still here, right? This 1 remains still here. But suddenly at t, what happens? This amplitude becomes 1. Here also it is staying 1. So this subtracts and it goes down. After that, what you are finding? There is a ramp function there, right? Ramp function. And ramp function is still 2t, right? 2t. And the value of the ramp function is 1. Amplitude remains 1, right? Amplitude remains 1. Now, if you notice this ramp function on the y-axis, if you notice, so if you take the slope of this function, what is the slope of this function? Dy by dx, right? So the slope of this function should be equal to 1. This is only possible if this is equal to your c. Now your x-axis is your 2 points, final point is 2t, the initial point is minus t, right? So this is your x point, right? This is corresponding to x. And dy point is your at 2t, at see, at the final point the value is 1, right? So this is your y2 and this is your y1. At y1 the value of this magnitude is becoming 0, right? Here. So you have at y2 minus y1. So this is 1 minus 0, right? 1 minus 0. So your slope here should be equal to, slope here is now equal to 1 by t. You can see clearly the slope is equal to 1 by t. 1 by t. So if you want to realize this function, okay, so you need a sloped function, which is an increasing ramp. Normally a ramp function is expressed, r of t is expressed at t into u of t, right? T into u of t. But this is a shifted ramp with a slope of 1 by t. So you will multiply the slope also. So it's an increasing ramp function. So it is starting from this t. See, if you notice here, it is starting from t minus 1, correct? And here also you multiply it with u of t minus 1. U of t minus 1, correct? So you need to add this and the slope also divided by t, right? So you add this increasing ramp slope there. That is this function you need to add there. Then finally at 2t, what is happening? It is again becoming equal to 0. So if it is again becoming equal to 0, what you need to do? You need to subtract that function. So now the new shifted ramp would be equal to t minus 2t divided by u of 2t minus 1 divided by t. So you subtract this function. So then you can realize it easily. So now you can see that if you want to stop this function, so you can easily see, okay, this has been asked in the gate examination. So you realize at 2t, the function should be equal to c. First, what you did, first you realize the constant slope, right? That you got from u of t minus u of t minus t. Okay, so this is the first part of the problem. This is the first thing that you realized. This first part you got. Now, the second part of this problem is the ramp function, an increasing ramp function, which is increasing till 2t, right? 2t. Till 2t, it is increasing this ramp function. Okay, and the slope of this ramp function is remaining 1. Okay, after 2t. Now you have to realize this rising ramp. Okay, rising ramp. In order to get this rising ramp, what you need to do? You need to add a ramp function. But you just check the slope, right? Slope there is 2t and t here, right? In the x-axis. And the magnitude is 0 and 1. So if this is your x1, this is your x2, okay? This is your y1, y2 and y1, y2, which is equal to 1. Okay, this is the final point, and y1, right? Here corresponding to y1, it is corresponding to the magnitude is 0, right? So here you will be doing plus 1 by t, okay? Okay, t minus t, because starting at this point, t minus t, and u of u of t minus t, t minus t. So it is adding. Finally, you have to bring this ramp down to again a constant function. Now, when you have to bring this ramp down and have to make it a flat line, and the slope should be equal to 1. So what you do, you need to subtract the ramp. So subtract the ramp from which point? Subtract the ramp from 2t point. So you'll just do u minus t minus 2t, t minus 2t. Again, the slope there, if you notice, would be equal to t into u of t minus 2t, t minus 2t. So like this, you will realize the function. So the answer to this would be this. Okay, this is the answer to this. Thank you very much. I will be coming with more classes on classical signals, classifications, and all that. Okay, thank you very much.